Hello, everyone. Welcome to join me in this course. Today's topic is the basic composition of industrial robot workstations. We live in an era where intelligence and automation are becoming increasingly popular, and the industrial robot workstation is exactly an important representative in modern industrial production. Have you ever wondered how those industrial robots that perform complex tasks in factories with precision and efficiency work together? What kind of workstation system supports them behind the scenes? Today, we will uncover the mystery of the industrial robot workstation together. In this lesson, we will introduce the following two aspects: the overview of the industrial robot workstation and the basic composition of it. Through this lesson, I hope you can describe the basic components of the industrial robot workstation and their functions, and give examples of its application in industrial production. Be able to analyze the composition structure of the industrial robot workstation and understand the cooperative relationship between its various components. Before we get into the details of the basic composition of the industrial robot workstation, let's first briefly understand what an industrial robot workstation is. An industrial robot workstation is an independent production system that takes the industrial robot as the core and cooperates with peripheral equipment such as positioners, conveyors, tooling fixtures, etc., to complete specific process operations together. It is an important part of industrial automated production and has the characteristics of high efficiency, high precision, and high reliability. Next, let's focus on the basic composition of the industrial robot workstation. It mainly includes the following parts. 1. Industrial robot. The industrial robot is the core of the entire workstation. It usually consists of three main parts: the mechanical body, the drive system, and the control system. The mechanical body is responsible for performing various actions. The drive system provides power for the mechanical body. The control system is the brain of the robot and is responsible for receiving instructions, processing information, and controlling the movement of the mechanical body. Industrial robots can complete various operational tasks such as welding, handling, and spraying. 2. Control system. It is the brain of the entire workstation and is responsible for controlling and coordinating the industrial robot and other equipment. The control system consists of both hardware and software parts. In terms of hardware, it is mainly the controller. It receives signals from sensors and programmed instructions, and then sends control signals to the motors and other actuators of the robot to achieve precise motion control. The software part is the programming environment and control algorithms. Operators can program the tasks of the robot through programming languages, such as robot-specific programming languages or graphical programming interfaces, setting parameters such as motion trajectories, velocities, and accelerations. For example, the control system can set the movement path of the robot during handling to avoid colliding with surrounding equipment. 3. End effector. The end effector is also called the tool end. It is installed at the end of the industrial robot and directly contacts the workpiece or working environment to complete various specific operations. For example, in handling operations, the end effector may be a mechanical gripper. Through pneumatic or electric control, it can achieve clamping and releasing of objects. In welding operations, the end effector is a welding gun, which can produce a high-temperature arc to melt the metal and complete the welding. The type of end effector is designed according to specific work tasks and also includes various forms such as vacuum suction cups for absorbing flat objects and spray guns for painting. 4. Auxiliary equipment. Auxiliary equipment is an indispensable part of the industrial robot workstation. They include positioners, conveyors, tooling fixtures, and so on, which are used to assist the industrial robot in completing various operation tasks. The selection and design of auxiliary equipment need to consider factors such as the working environment and the characteristics of the workpieces. 5. Sensors. Sensors are used to detect information about the working environment and workpieces, enabling the robot to respond accordingly based on actual situations. Common sensors include visual sensors, tactile sensors, and position sensors. For example, visual sensors are like the robot's eyes. They can acquire information about the shape, position, and color of the workpiece. Position sensors are used to determine the position of each joint and end effector of the robot, ensuring the movement accuracy of the robot. 6. Safety equipment. Safety equipment is an important measure to protect the safety of operators and equipment. They include fences, safety gates, emergency stop buttons, and so on. In the industrial robot workstation, it is necessary to set up perfect safety equipment to ensure the safety and reliability of the operation process. Through today's lesson, we have comprehensively understood the basic composition of the industrial robot workstation, including the industrial robot, control system, end effector, auxiliary equipment, sensors, and safety equipment. Every part plays an important role in the workstation. They cooperate with each other to complete industrial production tasks together. Lastly, I hope you can think about the following questions after class. 1. What impact will be caused if a certain component, such as a sensor, is removed from the workstation? 2. When designing an industrial robot workstation for a practical application scenario, how should each part be optimally configured? Thank you all for your participation. I hope today's learning can open a door of wisdom for you to industrial automation technology. See you next class.